Okay, what are we saying? We are saying generics. It is time for generics. Let's get into it. So, as you can see, the get nth parameter and get parameter by name functions are a bit strange. But what I'm going to do is I'm just going to implement a basically just, you see the way I have local variables here, string and a shared pointer to a variable, right? Well, I'm also going to have a vector of rs variable pointers, and we'll just call it parameters. So these are going to be, well, our parameters. Now, I know what you're thinking is that's probably been implemented already. It kind of hasn't. So I'm going to, gradually do that. But here you can see we can iterate through those parameters fine, right? Here is the only place that we ever insert, whether or not it's parameter. So, and I just want to say if parameter, then we can also insert, we can do parameters dot push back variable dot get. Okay, so we'll just add that functionality. We'll go back to instantiate generic function. So we're going to go through all the parameters, and we're going to say, well, we're basically going to do v comp info, type info, right? So the type info here is of type redscript type info, and there should be a bool here saying generic. And if generic is true, what we're going to do is generic. Now, if generic is true, we need to add that to our equals. So what are we thinking? Well, we need a bool generic, but I think it's better to do an int 32t generic ID and also a bool generic, right? So generic ID. So this is going to be -1, first of all. So, for example, in order for t to equal t, it must be t array equals t array here. But it also, obviously the generic IDs should be the same. But we can actually get rid of the generic ID, I think. we can just use the type ID for when it's generic. No, I think we gotta keep it. And I'll show you why in a minute. So let's just add in here. For a generic to equal a non-generic? Well, we don't know, do we? For a generic to equal a non... So imagine t equals 4. Yeah, we don't know. So we have to just say generic is other.generic and our generic ID equals our generic ID. And then if you're equating between a raw type, you need to make sure that we are not generic as well. Can convert to. So if another type wants to convert to a generic, well, we say not generic, basically. Not generic. Okay, seems to work. Then we need its, so what we're going to do here is we're going to change the type info.generic ID, and we're going to equal that to, hold on a second. Let's go for a second to var parse. And let's take a look, right? So we do type parse. So that's where we get our types for the variable. Here. Yeah, this is what we need to do. So we need to say if program dot current generic types okay, but there's a problem because current generic types is it's got a bool at the end. But what we really need is a pair of int and bool. And I'm just going to say here index is object type. That's what those things are. Cool. Cool, 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 cool. And now we can change get nth parameter to return quite literally just return parameters dot at p if parameters dot size is if p is less than that, and then we can just return null pointer here. And then here get parameter by name. We can just do for parameter. If we all we have to do is if var name is name return var. Very nice. So we just have references to parameters. Nice and simply put. So let's go back into parser, and we will do current generics. We're going to try and find. So we're going to say auto generic is program.current generic types dot find next of repr, and I can just do repr is next of repr, and we can, you know, save the double dereferencing and just use repr and repr. And then we say if generic does not equal program.current generic types dot end, then we can do type ID is generic second first. And what out here we can do bool generic is true. Sorry, generic is false. So we're gonna say here generic is true. Simple. Is generic. So that seems to be fine. And then here we can go to after type. Simply. What's after strict? Generic is gonna be is generic. And we can actually use, so we can say, instead of that, we can just use int generic ID and set that to -1. And then we can say generic ID is equal to that, right? So we actually don't care about the type ID. So if type ID is -1, we will do tinfo.generic is equal to generic ID not equal to -1. And then, you know, we can line all these up, why not? Then we can do tinfo.generic ID is generic ID. And then we can just do generic ID not equal to -1 and generic ID. So that's how we assign the types easily. Perfect. Aha, we have to change this. The entries of a generic should be yeah, it should be Okay, so here is we can't just do that, so we have to do generic type of generics entries, and we can do program.current generic types.insert generic type dot first generic, and then we need a pair generic program.current generic types.size is going to be the, and then generic type.second. So that's how we're going to merge these maps. Not the cleanest solution, but it works. Now let's go back up to our error. So we're going to set the types. So we know the generic ID is used to differentiate all that. But we have to just say rs type info reference info is the type info of v, right? And we say if the info is generic, this is kind of weird. Well, if it's generic, right? Okay, so T is generic. Then I need to search for T in the types of the function, in the generic types of the function, which is searching through this. And then if it's not found, then we have to use it from somewhere else. Okay, so I don't think generics will be allowed to be nested, unfortunately. The time being. So what I'm going to do is just quickly, when we find that not in call parse, in keyword methods, there we go, we can generics parse. What I'm going to do here is if program.functionStack.size is greater than 0. Yeah. Then we should comp error and say syntax error, nested functions cannot be generic. Save ourselves some of the pain of working that out for now. So what we can do now is go to generic, this one. So if a type info is generic, the index of the so if we do the generic ID is going to be the index. So all we have to do is the inf is equal to types.at_inf.generic ID. And then we'll have to say up here, if types.size does not equal to copied function. Wait, no. Copied function generics entries.size. Then we comp error, syntax error, expected. Say expected generic arguments provided. There we go. So we assign everything to the parameters. That's perfect. But instead of going through all the parameters, we know the parameters exist within the variables. So we can just go through the local variables. No, actually, we haven't parsed it, have we? We've only parsed the parameters. Yeah. Now we need to parse the function. Copied func. So we do program.currentFunction if so generic functions cannot have parent functions. So we can just do program.currentFunction is equal to copied function. and return copied function. One last thing we need to do is this types array. We need to go into, stop making it const for a second. Perfect. And then we need to make a field in our parser called a vector of type info, and we're going to call it, actually we can't make this const because we're just going to copy it anyway. And we're going to call this generic type conversions, and we can actually put that in program, generic type conversions. And we can do program dot generic type conversions is equal to types. Perfect. So now we can go to type parse. If we find a generic type, see if we can convert it. We are parsing a generic function call. So we can convert it by, how are we going to do this? We can convert it by saying if the program's generic type conversion size doesn't equal 0, then if it doesn't equal 0, then we know we can, well, we can just try a standard find. Wait a minute. Yeah, we can just say if it doesn't equal 0, or if the size, if our generic ID that we've passed in here is less than our size, then we can actually just straight away replace the type ID. We'll put an else in here, because we don't actually need it to be generic if we've changed it, right? So we can actually just set the type ID equal to program.genericTypeConversions.@genericID. Simple, right? What's wrong with that? Oh yeah, dot type ID. So we don't actually like oof. Actually no, we can't just do that, Because what if you have... Well, what if you have T braces, and then I did T of int array? So then it would turn into be int array array, wouldn't it? So... That's defaulted to 0, I'm assuming. Yeah. So what I can do actually is just set tinfo to be this entire type. Because we're using T there, right? And then if we have arrays, we can keep going. Yeah. And if we have, you know, optionals, T optional array, then we can keep going. Okay, that works. I don't know where if we can put the optional here or T. That's where it comes in a little bit weird. The optionals with arrays. T optional here is an array of maybe T's, and then T array is a maybe T array. So we'll have to fix that. But for now, you can see here if tinfo is equal to type ID is -1, we know it won't be when we convert the generic. So then here it's actually just going to put itself onto the other types, which is bad, bad, bad. So what I'm going to do is just make a bool converted from generic, and we can say converted from generic is true. And then we'll say down here, or converted from generic. Wait. Else if not converted from generic. So if we're converting it from a generic, put an else there. We don't need to change anything but the array count. So the array count is equal to array count. Well, actually it plus equals by array count. Because if we had one array count and we added another one, so int array, we'd actually have two array counts. Perfect. Okay. Almost ready. Almost ready. Next thing is... Oh yeah, so when we're parsing a generic function, we don't want to, when we finish the function, like if we parse a generic call, and that's our current function. Oh, wait a minute. Oh, wait a damn minute. Okay, so I have to go do parse instantiate generic function. Here, we need to actually simulate parsing ourselves. So size t before at is equal to where we're at right now, right? And oh shit. What if the generic is in another file? Uh-oh. Oh no, I was so close. What if the generic is in another file? Because remember, a week ago or a few days ago, we made it so every file is just the contents of that file as a token list is on a queue, and we erase thing from the queue when we're done with it. But with the generics, we actually have to go back and parse it every time, but I don't know where that is. So let's fix this by going to the function generics. We will need to get a shared pointer to a token list. File fragment. We need a project fragment. Where is this defined? It's defined below all this. Can I move that? Yep. Project fragment can go up here. Perfect. And we can just say from fragments. Okay. Anybody who's in the chat can say hi, by the way. Get my mind off this madness. So when we find a function that's a generic, what we can do is we can... Hold on a second. So for a function that's generic, we actually need to take the dot fragments fragment pointer q. This is getting way too out of hand. Aha, never mind. So we can actually just do generics, and we can say from fragment is equal to current file. Boom. So we keep that alive even though it's been popped. And we do assign the generics. Perfect. So now let's go back to instantiate generic function. And what we can do is actually take the... We can take the file fragment, project fragment, before fragment. So all we're doing is changing the fragment and where we're at. And then we'll change that after. So we'll say at is equal to before at, and before fragment before fragment is equal to current file. And we can just say current file is equal to before fragment. So in between here, we need to parse the copied function. All we do is do while wait, one more problem. Token list. Oh, my monitor cable fell out. So the token list pointer. Well, this is what we have to change. So I'm gonna make a nice helper function to just call setup file, use current file, call it underscore use current file, and it'll literally just be this, use current file. So we can go to parser, we can make this void RBC parser use current file. Yeah. And what we can do is just this. Literally. We can just call files front, files pop. So instead of doing all this, we can just save the before fragment, or the before file, I guess. And I'll copy this actually, and I will... No. We can do... Shit. Before file is current file, then current file is equal to before file, I guess. So if we have a before file saved, and then we call use current file, now do you know what I'm going to do? Is I'm going to rename this to use file, which will take in a project fragment reference. Yeah, and it's gonna be all this there. So we're just gonna call use file current file. Okay. Dereference it. Wait, no, use file use file current file. We can actually just take in the pointer and it'll be fine. Standard shared pointer project fragment frag, and then we can use that. And we can call use file with an project fragment reference frag standard shared pointer, and all we have to do is take out these 3 lines. Don't know why that took me so long. So we can, instead of calling use current file, we can call use file Damn it! I should have done it this way. No, 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 no. Oh my god. Because it's the way advance works. Okay. Let's fix this. Use current file. And then we can change all this to use current file. So if I assign before file to current file, and then I assign current file to the fragment of the function, so we do copied function generics from fragments. So this fragment contains all the information about, all the tokens that it was in. So we call use current file, and that gets everything used up really well. But what I want to do is if I have a file 1, 2, 3, 4, and it's a queue waiting to get in a door, right? So they're waiting to get into a door. And 1 is this file, but the generics function is located in 3. We're going to say, well, if I say generic is G, and then the 1 is current, right? We're going to say B is equal to C, right? So then we can just say, wait, no. G wouldn't be in the, G would be already parsed, to be honest. Yeah, it would be already parsed. So what we do is we change the current file, but we save the file before. So B is equal to C. B is equal to C. And then we do, to get into the door, we say, okay, C is equal to generic, and then we just replace this with generic, right? So we start parsing generic. We finish generic. We need the C to be inserted here, but it's a queue, unfortunately. But I think I should be able to get around that. What we're going to do is we're going to use the current file, and then files, insert, C. Wait, no, there's a function for this, I think. I'm going to watch it in a couple of minutes. Can you tell me for now, hi Shad, if you've seen Squid Game, and especially Season 3, and if so, what you think? Is Season 3 out? Okay, my rundown of Squid Game, I have seen it. Season 1 was really, really cool. I loved it. Had some problems, but it was really nice twist. Season 2, first episode was brilliant, and the next, like, everything else was pure horse shit. Yeah. That's about it, I guess. So First season, I'd recommend watching. First season, definitely. Second season, the first episode was probably better than any episode in the first season. And then they just... I won't spoil it. I won't spoil it. But season 3, I guess I'll give it a watch tonight, I guess, yeah. I've been waiting to watch that. If you think season 2 was besides First Step Dogwater, then you won't like season 3 too, personally. I didn't like it. Alright, see you, man. Yeah, it was pretty weird. So what we're gonna do here is... we're gonna insert C++Q. What methods does it have? It has mplace, push insert element at end, mplace construct element in place at the end. Pushes a new element to the end of the queue. The element is constructed in place, no copy removal. Ah, so I should be using double-ended queue. So rename U to fragment pointer DQ. Well, we can rename it again to just DQ. And then we can find the type def and change it to a standard DQ. Define a header DQ. Okay. So now the DQ is included. We can do there'll be some problems here with files.pop front. Yeah. Up here we do files.pop front. So we use the current file. Now we can do files.push back or front. Push front. So we just push front. u. That's what we push front. Okay, it's working so far. What languages do I know? Like in real life? I know a little bit of French. I speak a little bit of my Irish language. We speak Gaeilge here. And English. What about you? I know you know Polish. So we use the current file. Crazy? Ah, look, I'm not fluent. I'm not a French person who knows English. I'm an English person who knows French. You know what I mean? The difference. So we can actually just finish this and say at is... Can use current file like so, and then at is equal to before at. So we just... keep parsing like nothing happened. I know English, Polish, and I'm learning Japanese since 2.5 hours. 2.5 years. I taught German at school for 6 years straight, and I don't know a single thing. I never liked the language. German is... Yeah, I have some friends who learn German. They say it's good. Yeah, hours have been funny. That's crazy. I mean, you know English and Polish, and you're definitely fluent in English, Jesus. And learning Japanese is really, really good. How's it going? Is it a tough language up there with Russian? For me, Russian would be easy because it's a Slavic language. Okay, fair enough, yeah. But like in terms of worldwide difficulty. I also realized generics need to have a size T, begin and end. Great. So I need to go, you know, change that. So when we go to a keyword method and we have generics, we can say that the begin is sorry, 1 second. Bracket open. So generics begin is equal to at, and then generics end is equal to at. So we now have, yeah. Japanese at the start is a completely different world, but after getting used to it, the only hard thing are particles in grammar. They are particles in grammar? What the fuck are you on about? They're simple by themselves, but insanely hard to math. Do you mean like pronunciation? Also, can't forget about hearing, because there's a couple of words that have the same pronunciation. Oof. Like in different sentences. And Japanese people just read so fast. Yeah, so do French people. Jesus, they talk so fast. No particles, like there's a topic marker, object marker. Oh my lord. Brother, I would not learn that. Just learn brainfuck, like. What are you looking at? So now I go to parse instantiate generic. I'm almost done. Almost. Topic marker is similar to is. What do you mean? I don't know what you mean. So while, so we can say at is equal to copied function generics begin. And then we can say while advanced, and we can just say size t end is copied function generics end while advanced, and at is less than end parser, or we just call parse current. Perfect. So we're simulating a parsing of the function, and obviously if something goes wrong, it's thrown. Topic is topic marker something. This is far from reality, but yeah, I still have no idea what you mean. I will never learn those languages. Like I'm telling you, French is parfait pour moi. It's like just, you know, learn the verbs. I'm English, so I suck at languages. Like, so I've pushed front a new file. I'm now using it so it's popped from the stack, from the DQ. Then I set where we're supposed to be to parse the function. I set the current function we're in. I set the generic type conversion. So we've parsed in like int, for example, int array. So if it ever finds t, it will go look in generic type conversions and it will find, okay, t is now int array, so just paste it in. Then, while we're not at the end of our function, now because generic because generics can't be nested, generic functions can't be nested, unfortunately so. We need to know the scope of the function and set that to, so actually we know what it is. So program.current scope is equal to copied function scope. But I will need to save the old scope. Program.current scope. Need to save all these. Right? And then I will say old scope is equal to, sorry, program.current scope is equal to old scope. Looks fine. So what we're changing, we're making amends for. So while we're parsing the old generics function, we go through, and when we find a type, we snip it in by using generic type conversions. Works. Okie dokie. Then we return it. Now there's a problem where while at is less than end. So end is the index of the curly bracket. So if at becomes the index of the curly bracket, we don't actually push the function onto the stack of functions, onto the list of functions, which is really good. So we like right before that last curly brace, we end it. Then we go and take that entire function. Do you have or plan on supporting lambdas? Tell me what the difference is between a lambda and a nested function. So I think we're done. Now, name mangling needs to be used. So a lambda typically captures some variables. A normal function, but a nested function can. Like in my language, if you have method void x and you do y, which is an int, is 4, and you make a method void z, you can access y fine. You can access it fine, and then you can call z wherever you want below it. That is a lambda, right? Like this is already in the language. Then it's a lambda, yeah. I guess so. Fair enough, yeah. Fair enough. So I do have, they're already supported. Didn't think I could say that before. So now what I'm gonna do is pray this works. So I'm actually gonna just get rid of all this and do a generics file. And what we're gonna do is we're gonna use lang. I almost write include lang. So if we have code like this, int a is 5, function b. Yeah, you can send on Discord if you want. A is 5, function b, a is 2, function c, a is 0, b, say a. What is your lang gonna say? It says 2. No. Yeah, it says 2. Pretty sure. Let me see. A is 2. Yeah, it says 2. We can test that out if you want. Hopefully I didn't fuck it up with generics. I'll test it out here. If I write a lambda red script file. Yeah, let's test it out. Let's use lang. Actually, let's not use... Wait, we should use lang. But you see, I've just screwed up the lang file. No, I got rid of it. Never mind. So let's go into here and we'll write the function. So we will do... Let me just copy your code. So method void b. And you want method void stuff inside it, right? Wait. You gave me 3 functions. But you're not talking about lambdas here. You're just talking about normal function calls. There's no nested function here. Oh, so you really so you just want to know how it would work normally. Okay, yeah, that's fine. Well, let's see if it works. Hopefully it does. I haven't actually ran this in so long. So void a is 5. Void b is a is 2, and then method void c and call c. Okay, let's try it. Let's build. We will compile. My lang would have a scope bug that would, in this case, print a is 2 at say. Sorry, this should be message at or. A. But it would overwrite the A inside B and not the global A. Oh, the keyword here. That's a good question, because you want to redefine it, right? I'm pretty sure this will give an error. Pretty sure this will give an error. Okay, I don't know what's going on. I can't even cancel the... Like, it's not even running. It's just sitting there. Hello? What the hell? Yeah, here. Variable cannot be reinitialized, but with a different type. So, you know, global variables... That's a bug. That's a bug. No, there wasn't an infinite loop. I don't know what happened there. I just hadn't used that terminal in like 3 hours, so it just kind of shut down. That's the bug. Because I would say we just differentiate them based on their scope, right? No, it's the error means that if I have a is int is 5 and then I do a is int is 10, you can't. Oh yeah, wait, what? Cannot be reinitialized with a different type. Oh yeah, you're right. It should be cannot be reinitialized with the type again. Cannot be reinitialized with a type. Reinitialized again. That's it, really. Yeah. Cannot be yeah, pretty much. But yeah, you get the gist. That's just me writing bad errors. But that's a bug, so now I should be differentiating the variables, which I will do, actually, right after I finish this. So I'm going to compile generics and get maybe 7,000 errors. Just trying to think, have I missed anything? So when I call instantiate generic function right here, we set the function. What the hell is... Yeah, we set the function equal to the compiled function we've just compiled. So I guess the test and the question boils down to, do you keep 2 scopes per function? The context in which the function was defined and also the current running time. So the way it works in my language is actually... it doesn't matter about scopes. So I can actually implement what the bug I'm talking about really easily. Like a variable outside and a variable inside. The only problem I have with them is they're the same name. But when they're run in the program... for Redscript in Minecraft, they use indices because it's faster. So they're always distinguished, if you get what I mean. So I'll fix it in 2 seconds. 2 seconds. So what I'm going to do here is instantiate the generated generic function. Then that's our function. Then call our function with our parameters. Simple. Sure, but even if they have the same name, you can distinguish them by scope. Exactly, yeah. Yeah, that's what I meant, yeah. So when we call advance... Oh, this is going to crash so hard. Advance, and then this function is now generic. Yeah. But you see, now that I'm assigning function, what I'm gonna do is do this. I'm gonna do function generics. We know the generics exist because it is a generic function, I think. Wait. If negative function generics, obviously we can't do that. We have the comp error, syntax error. You are trying a function with no generic cannot be called with generic with template arguments. So now we know generics exists. and we can do the generic variations. There we go. And we can insert what is variations? See, we distinguish it based on the type info, and I've hashed this already. You can like append the scope index to the variable name. You can append the scope index to the variable name. Not a bad idea, but then I'd have to reference that everywhere else. Nah, but you see, like, if you had int a outside and int a inside, oh, after semantic check, yes, you could, yeah, that's true, yeah. So what I'm gonna, why is the variations got type info? Oh Lord. Wait. Is a vector hashable? Do you know that? Is a vector hashable C++? The template specialization of standard hash for vector bool allows users to obtain hashes of objects of type standard vector bool. Okay, but why only bool? Unordered map requires availability. Sorry, you can't see this. Let me. Unordered map requires availability of hash function for the key. Such function does not exist for vector. You could use standard map though. It requires comparison operator which exists for vector. If you really must use vector as a key, you should implement hashing function yourself. You should point out that doing this might not lead to the same. Yeah, okay. If it works in map, I'm just gonna change straight to map. Like, I'm not gonna lie. Let's just change this to a map and include that up here. Okay, we already do. So it's a map of of vector. The reason the key to the map is a vector of type info is because obviously each different generic instantiation of a function will have a different vector of thingies. Yes, thingies. So we're going to insert our types and our compiled function. Oh, that is satisfying. Oh, that is satisfying. So the function pointer before we assign it is going to add it to generics. And down here, nothing else happens to function. my lord. Let's go to ChatGPT for this. How can I fix this error? Using key of standard map as standard vector type info, and type info is hashable. Right, so I need to define a comparison operator for type info. So I'll just do an inline bool operator less than and type info right hand side, and I'll return that. See what the errors we get now. Okay, alright. My god. Self-comparison always evaluates to true. Warning, current function will be initialized after. Oh yeah, sorry. Context, then current scope, current module, current function, global function needs to come after current scope, and last scope comes after global function. Then generic ID should be a, well, I would like to cast this to an int. It should be a size t. Fragments.push is not liking it this. What is fragments? Push back. Apparently I'll need a reference to these. Like that. Holy Jesus Christ. Does it hate me that much? Okay. I still get this error. So much text. So apparently we should include map before type info. Okay. This is a good song. Okay, apparently that's supposed to fix it. I don't believe that for a second. Um, oh wait. Just thinking for a second. So apparently it's asking me to use standard TIE, standard TIE, but I've never heard of this in my life. So oh my god, what did I do? Right, time to use an unordered map, I think. Because this is getting too annoying. Okay, it's asking me to paste this. Like, brother. Holy Jesus. I just gotta label all these fucking methods as const. Hmm. Oh shit, I already made that. Okay, let's get rid of parsing range. We can just keep the begin and end in the function generics. Okay, what are we saying? It's compiling, chat. It's compiling. God, don't give me a seg for. Oh my lord. Oh yeah, that's because I didn't add type info HPP. Wait a minute. What? Undefined reference to write MC. How? Deleting my build folder usually fixes it, by the way, so we're gonna try that. Yep, that fixed it. Well, all of that code and it didn't work. Oh no. Expected generic name. I'm gonna go insane, chat. I'm gonna go insane. So that's in parser CPP, expected generic name. And you know, actually quite weird because, well, let's just break. Let's go into the GNU debugger here. Then run examples or break at parser CPP 612. Run examples generic thread scripts and give it some arbitrary file. Okay, p current token. Okay, so it needs to be out here with an advance and then in here with an advance. No, 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 no. It needs to be two. If current token info token, if it's not a comma, we're gonna comp error, syntax error. No, wait, that's fine. So after the T, we advance, and then if it's a comma, we advance again. Yeah, we need to say this. Unexpected token. Just assign that here, so we don't have to keep dereferencing everything. Standard out of range. Oh shit, it worked. Warn unimplemented type. Why is that a warning? Why isn't it an error? uh, well, let's see what it compiled anyway. Well, let's see if we can do this. We can. And can we do this? We can. So I don't think it's getting parsed at all, to be honest. Let's take a look. Oh my lord, thank you, Bing. Instead of giving me the fucking folder. So let's go into Redscript testing, data packs. We called it X. So Redscript testing just doesn't even call it, and X is empty. Okay. Get off to a splendid start. Let's go to call parse. Let's start debugging this. So let's go into GNU debugger. Let's break at parser CPP 734. Run examples generics. Doesn't seem to be working. Oh, I know why. I know why. It's because it doesn't know what this is. Like, it doesn't know it's a function call, you know? So how are we gonna fix that? How are we gonna fix that, chat? I am having a brain aneurysm. Okay, well, what I'm going to do is I'm actually going to include the option to just bring in your own standard, bring in your own function to this. So function like that. Call it just f, I guess. And then I just say if not f, got to do all of this. Now I can take this code out and I can go down to my token type word. If follows token type symbol with info of this, I want to just grab all of that like so. And then else like that. Now we need to get the function. Okay, never mind. What we need to do is get rid of u. And we need to add in function generics. So all we need to do here is down here. Oh my god, sorry. This is actually supposed to be a shared pointer to a vector of RBC type info. Generic types. Let's copy all this again. You can say if not call parse word.repr true null pointer and types. Pass in the reference of types. Abort parse. Now let's go back to this error, where we will now take in a shared pointer to a vector of RBC type of RS type info, and this type info will be, well, once we have the function, we can say if the function doesn't have generics, if our generic, we have generics and the function doesn't have generics, then we can do that. We can get rid of u. So what I'm going to do is I'm actually going to just put u all in there. If not generics, then we can comp error. Okay, let's go back here. All we want to do is do this. And what I'm actually going to do is change this to be a vector pointer. Okay, so let's quit and build. Compiled successfully, and No, it hasn't. I'm confused. I got rid of that warning. What the fuck is going on? Wait, I thought I just got rid of that. Okay, so it might be actually something to do with my Lexer. I don't think I've added it to the list of symbols. I just close this and say, okay, we're pushing back the type of a symbol with the character. And then we go into parser. Let me just go into this and then break keyword word 1040. Let's go back into parser and this is 60. Oh my lord. Whoops. So that'll work. But then find a method, and the token right after method is 60. Then we parse all the generics. We advance. Oh my god, I'm going insane. Break at Uh-huh. I see. I need to All right, guys, I'm gonna call it a day for there. I'll talk to you guys soon enough, though. Thanks for tuning in. I'll see you guys soon.